At Farris, we proudly provide processing facilities with total pressure relief management solutions. Let's take a look at why it's so important to have the right pressure relief valve for the right application. Direct spring-loaded pressure relief valves use the mechanical force of a spring to keep the valve in a closed position until system pressure rises enough to counteract the spring's mechanical force. Spring-loaded pressure relief valves are widely used throughout processing industries, but some applications and processing conditions require a different type of relief valve design. For example, back pressure, or elevated pressure within the header system, can prevent a conventional spring-loaded relief valve from operating as designed, because it results in additional forces that must be overcome to open the valve. This is especially true for variable back pressure. An alternative for spring-loaded valves is the balanced bellows design, but it also has limitations in high back pressure conditions. A potential solution for operating in high and variable back pressure conditions is a pilot-operated relief valve. Pilot-operated relief valves, or PORVs, can address applications that standard spring-loaded designs cannot. With PORVs, the main valve is sealed using system pressure regulated by a separate valve, or control, called a pilot. The set point and relief event are controlled by the pilot, which is isolated from back pressure, so PORVs are generally unaffected by back pressure. Pilot-operated relief valves also optimize production pressures as close to set point as possible, reducing fugitive emissions or product losses. And PORVs have a smaller footprint and don't usually require costly piping changes. In normal operating conditions, a pilot directs system pressure to the dome of the main valve. This pressure keeps the piston sealed. Without any disruption in system pressure, the main valve will remain closed. The surface area at the top of the piston is greater than the surface area of the seat. This provides a greater closing force to maintain the main valve in the closed position. It's important to note that as system pressure increases towards the set point of a PORV, the seating forces increase and the seat gets tighter. Let's say a pump has failed downstream and pressure is accumulating in the facility's processing equipment. A pilot-operated relief valve is experiencing a rapid rise in pressure towards its set pressure of 100 psi. As the pressure increases, the pilot control's piston assembly rises, lifting the spool and closing the inlet seal. These actions shut off flow to the dome of the main valve. The pressure within the dome does not continue to rise, and dome load remains constant. The main valve has not yet opened, but the closing force at the seat is slightly reduced. As the pressure approaches the system's set point, the pilot control's piston assembly continues to rise, lifting the spool, causing the outlet seal to crack open. When this happens, pressure in the dome will empty back through the pilot. This reduction of pressure within the dome reduces the seating force. In the main valve, the piston lifts off the nozzle, and excess system pressure is discharged directly through the outlet of the main valve. The main valve and pilot will lift in proportion to overpressure to relieve only the amount necessary to resume normal operating conditions. If enough pressure is relieved, the dome will repressurize and the piston will begin to reclose. If the system pressure continues to rise past 100 psi, the dome pressure continues to drop and the main valve opens further. Within the pilot control, the piston assembly rises and the outlet seat continues to remain open. Eventually, the dome pressure drops to zero and the PORV is fully opened and flowing. The pilot-operated relief valve design allows the system to operate very close to set pressure. The modulating control is critical in process environments where processors want to minimize the loss of hazardous or critical materials. As system pressure returns to normal, the PORV's main valve will close. When the piston reseats on the nozzle, the flow through the outlet is shut off. At the same time, the pilot returns to its normal position with system pressure flowing back into the dome of the main valve. Another benefit of a pilot-operated relief valve is the ability to add accessories, which further enhance performance. Installation of a reverse flow preventer assures that correct pressure differential is maintained and the main valve remains closed in normal operating conditions. By using a pilot-operated relief valve with a remote sensing option, the pilot is tubed directly to the equipment in a more stable pressure zone, bypassing the inlet piping and avoiding a pressure drop. And a field test connection allows maintenance personnel to check the set pressure of a pilot-operated relief valve without taking the valve out of service or disrupting system protection. To learn more about how we can develop the right solution for your facility, contact your local Farris representative.